Okay, this is a tutorial on how to draw Lewis structures. The first thing I'm going to show you is I'm going to outline the rules that you must follow to draw Lewis structures. Second off, I'm going to give you guidelines for how to connect the atoms. And finally, I will go over 3 or so examples of Lewis structures. I'm going to show 2 different ways to draw them following the rules and the guidelines. And let me just mention that these notes I'm going to save as a PDF and save it on my website, which is chemistrysky.com. So you don't have to take notes. You can download them. Okay, so Lewis structures are two-dimensional drawings, and I want to emphasize two-dimensional, so they don't have to show the proper three-dimensional structure of what you're drawing. Two-dimensional drawings of molecules, diagrams really, of molecules. They show 2 things: how the atoms are connected, what atom is connected to what in the molecule, because remember, Lewis structures of molecules are 2 or more atoms held together by covalent bonds. And they also show where the electrons are. And there are going to be 2 types of electrons. They're going to be shared electrons, and I'm going to abbreviate electrons with an E-. Shared electrons are bonds, and unshared electrons we're going to call lone pairs. And they're only on 1 atom. The bonds are connecting 2 atoms. Okay, so here are the Lewis rules first. And I will try to write a little bit bigger here. Okay, Lewis rules. The first rule is that the total number of electrons in your picture, your diagram, must equal the sum of all the valences. You can't spend more money than you have, and you can't use more electrons than you have. Okay, and remember, just to remind you, the valence electrons include both S and P. The S and P electrons in the outermost shell. Also you have to take into account any charge. So if you're drawing a polyatomic ion that's negative, you have to add extra electrons, and if it's positive, you remove electrons for ammonium. Okay, and then the other rule is the octet rule, which states that every atom in your Lewis structure has to end up with 8 electrons. And remember, 8 electrons is the same as 4 pairs of electrons. All electrons should be paired in your final diagram. And with the exception of hydrogen, which ends up, we can say, which gets only 2 electrons or 1 bond. So hydrogen should always only have 1 bond. If you have a hydrogen with more than 1 bond, you know it's wrong. Okay. So the way the diagram is going to go is that a single line is going to be a single bond, represents a single bond between 2 atoms, and the single bond represents 2 shared electrons between 2 atoms. A double line is a double bond, 4 shared electrons between 2 atoms. A 3 line is a triple bond, which is going to be rare, which are 6 shared electrons. And if you just have 2 dots, that's a lone pair, and those are 2 unshared electrons. And just to just sort of ahead of time, just to talk about this, so shared electrons count toward both octets of the atoms they're connected, toward both or 2 different octets, both atoms they're connected to. Lone pairs only count for 1 octet. So bonds are always going to be more efficient ways of using electrons, because a single bond, which is 2 electrons, they count towards 2 different octets. A lone pair only counts towards the atom it's connected to. Okay, so now we're going to talk about how to connect the atoms. Okay, and this is what I'm calling Lewis guidelines. So these are not necessarily hard and fast rules. You'll see that, but at least give you an idea of how to connect your atoms for connecting atoms. Okay, so we're going to make a little chart here. Atom, group, valence, number of bonds, and then we're going to draw the electron dot diagram for that atom. Okay, so we'll start with hydrogen. Group 1, valence of 1, has 1 electron, so the electron dot diagram is going to be to that. Okay, and I'm going to put an always here. Always. Hydrogen always forms 1 bond. So underneath here, I'm going to erase this in a second, but I'm just going to do a Lewis structure. So if we have 1 hydrogen with 1 dot, another hydrogen, another dot, and when you draw them, you should draw them facing each other so you can connect the dots. So then a hydrogen molecule, so H2, would be 2 hydrogens, connect the dots. And when you draw it that way, notice that this hydrogen ends up with one bond, so it thinks it has 2 electrons. This hydrogen has 2 electrons, so that bond counts towards both octets. Okay, and that would be the diagram for H2, and I'm going to erase that now to finish my chart. Okay, all right. Okay, so then next we'll do the halogens. Fluorine, chlorine, bromine, and iodine are in group 17 or 7A with a valence of 7. So a chlorine would look like this. 1, 2, 3, 4. And then when you draw an electron dot diagram, 1 electron per side before you double up. And I don't know how I ended up with that extra dot. And then you start doubling them up. Okay. And so notice that the halogens start out with 7. So if they only want 8, they're going to form 1 bond. But we're going to call that usually. That's why these are guidelines, not hard and fast rules. Okay. So then next we'll go to oxygen, sulfur, selenium, which are in group 16 or 6A with a valence of 6. So an oxygen would look like this. 1, 2, 3, 4, 5, 6. Notice it already has 6 electrons, only needs 2 more. So we're going to say usually 2 bonds. And notice because it forms 2 bonds, if you've drawn a picture, you can always put it in between 2 things because it just forms 2 bonds. But that's going to be a usually also. And then nitrogen and phosphorus, group 15, moving right across the periodic table, which is the same as group 5, a valence of 5. So a nitrogen would look like this, 1, 2, 3, 4, and really only have 1 lone pair and 3 looking for 3 more bonds, needs 3 more electrons. So we're going to say 3 bonds. Okay. And then next we have carbon and silicon, group 14, or group 4A with a valence of 4. So a carbon would look like this. And so since it only has 4 electrons, it needs to form 4 bonds, and we're going to give that an always too. Okay, so carbon's always going to form 4 bonds, and nitrogen generally going to form 3. These are usually going to be in the middle of your diagram. And hydrogen and halogens, which generally want 1 bond, well, hydrogen always only 1, and chlorines generally, these are generally going to be on the outside of your molecule. Okay, so now let's, one more rule. Okay, one more rule, which I call the uh-oh rule. That is, if you connect 2 O's together, you go, uh-oh, it's wrong. So there's no O-O bonds. The one exception is peroxides, because H2O2 is hydrogen peroxide, and OO bond is called a peroxide bond. So that's the one time. But when you have, what that means is in polyatomic ions and other molecules where you can have another nonmetal, the O is always going on the outside. And And so because of that, we're going to have to move electrons around. So here's kind of another Lewis structure rule. Use pencil or erasable pen so you can move electrons around in your diagrams. Okay, so now we're going to do some examples. All right, so okay, and I'm going to give you two methods for drawing them. One we're going to call connect the dots method, and the other is going to be draw, add an octet, and then count. Okay. Now, if they're both correct, they both should give you the same result. So the first one we're going to draw is chloroform or CHCl3. Okay. Connect the dots. We're going to have a carbon in the middle with its 4 electrons. So connect the dots. You start with electron dot diagrams of the atoms. And then we're going to put the H up here with its 1 electron. And notice I'm going to draw the electron on the side of the carbon. And we're going to draw the Cl. So each Cl is going to have 7. And I'm going to leave the single one facing the carbon. 1, 2, 3, 4, whoops, a Cl, 5, 6, 7, Cl, 1, 2, 3, 4, 5, 6, 7. Then we're going to connect the dots. So a line is 2 atoms. So now the lines represent the electrons being shared. And so notice all the atoms in this picture have an octet. So for example, the hydrogen has its 2 electrons. The chlorine on the left has 3 lone pairs and a bond. In fact, each of the chlorines has 3 lone pairs and a bond. That makes 4 pairs of electrons. And even the carbon has 4 bonds or an octet. Okay, so that satisfies the octet rule. Okay, so now we're going to do the draw then count method. If you have CHCl3, you probably know that you're starting out with a carbon. So the carbon's going to be in the middle, we said that, and the H's and the Cl's are going to be on the outside, so we'll just put them there. H here, Cl here, and so notice here I'm not starting with dots, I'm starting with lines. But now we're going to give all the atoms an octet. The hydrogen has its 2, so the chlorine on the left needs 6 more electrons to have an octet. The chlorine on the bottom needs 6 more electrons to have its octet, and this chlorine on the right needs 6 more to have its octet. Now, all the atoms have an octet, and the hydrogen has 2, and so that also satisfies the octet rule. But because we just added lines and dots, we must count to make sure our picture has the correct number of electrons. So we're going to add up all the valences. The carbon had 4, the hydrogen had 1 valence electron, and we have 3 chlorines. They each had 7. So this picture should have 26 electrons, and it does. Okay, so that's correct. Now we're going to do another one where, okay, we're going to do hydroxide. Polyatomic hydroxide. So with connect the dots, 1, 2, 3, 4, 5, 6 for my oxygen. My hydrogen here with 1 dot. Connect the dots. And notice the hydrogen has its 2, the oxygen's missing an electron, but we have 1 more electron because hydroxide is negative. So we're going to put that extra electron here, and then that satisfies the octet rule. Okay, and we'll just draw it like this to be correct. Okay, now with the just draw and count, let's say if it's OH, it has to be that. And then we'll give the oxygen an octet, and then we'll make sure our picture has the correct number of electrons. The oxygen has 6, the hydrogen has 1, and then we have 1 more for the negative charge, and 8, and the picture has 8 electrons. Okay. All right, and then I'll just do one more example of a polyatomic ion nitrate. Okay. With connect the dots, we have nitrogen in the middle with 5 electrons. The oxygen's on the outside, and I'll draw these correctly with the 2. And remember, notice I'm putting the single electrons facing the nitrogen. 1, 2, 3, 4, 5, 6. Okay, connect the dots. Now, the problem here is that, and also we have an extra electron because of nitrate, so we'll put that extra electron on that oxygen on the left and call it negative. Now, the problem here is that both the nitrogen and the oxygen on the left have octets, but we have 2 oxygens that are missing octets, have an unpaired electron, and they're not even next to each other, so we can't bond them. No, we're not making a triangle. So we have to erase and move electrons around, which is why we'd use pencil. So I'm going to erase one of these. Oh, I erased my nitrogen. I meant to erase just the electron. So we erased one electron there, and I'm going to put it there. And then I'm going to erase I'm going to erase the electron that's hanging out there on the right, and then put that over here. So we form a bond. Now the oxygen on the right has an octet, and the nitrogen has an extra electron. It has 4 bonds, and a lone pair. So a single electron. So we're going to erase that single electron and put it on the oxygen here. So notice whenever I can move electrons around, but for I'm not adding any electrons to the picture. If I erase a dot, I put it in a different place. And now notice this picture satisfies the octet rule. Oxygen on the left has 1 bond and 3 pairs. Same with oxygen on the bottom. The one on the right has 2 bonds and 2 pairs. The nitrogen has 4 bonds. So this satisfies the octet rule, and in fact it resonates. It doesn't matter which oxygen you put the double bond on. Okay, so if we're going to connect the dots, we would put the nitrogen in the middle, connect our 3 oxygens. That's our draw. Okay, now the octet, let's give every atom an octet. And I seem to have an extra dot here, besides all that other stuff. Okay, so now when you count electrons in this picture, you'll see that it has too many electrons, because we add up all our valences. We have a nitrogen with 5. We have 3 oxygens that each have 6 electrons, and we have 1 extra electron for our negative charge, but that only adds up to 24. And this picture has 26 electrons. So we have 2 electrons too many. And when you have 2 too many, that means you need 1 multiple bond. If at this point you had 4 electrons too many in your picture, you'd need 2 multiple bonds, which means somewhere you'd need 2 double bonds or a triple bond. In this case, we have 2 extra electrons. We need 1 double bond. So we're going to erase 4 electrons. I'm going to erase 1. I've erased 4, and I'm going to put back 2. And then I end up with the same answer. And then that picture has 24 electrons. And that's it.